Hello and welcome to yet another question where we try to solve a linear problem using simplex method. Now we have seen up till this point that so long as we have two variables, it is always good that we solve a linear problem using graphical method, because simplex being an iterative process, at times it can get a bit lengthy. So up till this point we saw the first question got finished in 2 tables, next one to 3 tables. Now today we will expand this journey a little bit more. Today we will see that we will take 3 constraints. Up till this point we have taken questions which had 2 constraints only. So today we will take a question where we have 3 constraints, and we will see how smoothly this process flows. Yes, in the beginning it can seem to be a lengthy process, but today we will see that how smoothly this process can flow. Today again we are taking a canonical form where the objective function would be maximization and all the inequalities will be less than type. Now up till this point we have taken only less than type inequalities. Reason being, because as soon as you come across greater than inequality, you need to make some alterations to the method. So before we get into greater than inequalities, our idea is that we should be very comfortable with simplex process. This flow of simplex should be very convenient to us. We should be able to move from one table to another, so that when we come across this greater than inequality, we are not at least puzzled with simplex problem. Simplex should be easy so that we could learn more new things over there. Otherwise, we will be confused that if I am not able to understand the new thing or I am not able to understand the simplex. So first we will try to be very comfortable with simplex, and then we will talk of the other methods. So we will write down the question over here. It is a canonical maximization with all less than inequalities, and then we will move forward. So it is Zmax is equal to 20x1 plus 30x2. Zmax is equal to 20x1 plus 30x2. Subject to 3x1 plus 3x2 less than equal to 36, 5x1 plus 2x2 less than equal to 50, and last one would be 2x1 plus 6x2 less than equal to 60. And also there is a physical constraint which suggests that all the variables x1, x2 should be greater than or equal to 0. Fine. So this is our problem. We'll put up some other color over here. This is our problem that has been given. Now this problem could be given directly, or we could have formulated this problem. The idea is now we will solve it. So when we go ahead to solve it, first 2 steps are converting the inequalities into equalities, canonical into standard form, using slack, surplus or artificial variables. Up till this point we have only learned slack. You can use slack, surplus or artificial. These two are represented by small s, this is represented by capital A. Up till this point we have only talked of slack variable. For surplus and artificial, there are other methods, there are advancements over simplex. So we will see them when we get there. For now we are only taking slack variables because everything is less than type. So let us convert these inequalities into equalities using slack variables. So these get converted into 3x1 plus 3x2. Now this is less than 36, so I will add something. I will add s1, making it equal to 36. Second one is 5x1 plus 2x2. Again I will add something over here because this is falling short of 50. This is less than 50. So this slack would be s2 is equal to 50. Next one would be 2x1 plus 6x2 plus S3 equal to 60. So now I have converted all my inequalities into equalities. The next step is incorporating all these new variables. We started our discussion with Z, X1 and X2. But now I have 3 more variables, S1, S2 and S3. So now I need to incorporate all these variables into Z also. How do we do that? Zmax is equal to 20x1 plus 30x2 plus these 3 variables, 0 into S1 plus 0 into S2 plus 0 into S3. Now I have included all these variables in my objective function. So this is how I start my simplex. Now if someone asks that what is your IBFS? IBFS is determined by putting all decision variables and surplus variables as 0. We are not making use of surplus variables, all I am using is decision variables. So I will put all decision variables 0. If this is 0, x1 is 0, x2 is 0. This is gone, I get S1 is equal to 36. These two are 0, x1, x2, decision variables. x1 and x2 are decision variables. x1 and x2 are 0, so S2 becomes 50, S3 becomes 60. So a starting point, my IBFS. What is my IBFS? My IBFS is S1 is equal to 36, S2 is equal to 50 and S3 is equal to 60. This is my IBFS. Now let us prepare our first simplex table. Now because we have 3 different constraints, so our calculations are going to be lengthy one. So what I'll do is in order to save the board, I'll put my first simplex table over here itself. What is the format of the simplex table? We have variables. Theta is our decision variable. B is our solution. Number of units, it could be cost, it could be rupees, it could be number of, generally it is number of units. Then there are 3 slack variables, S3, S2, S1, X2, X1. Their respective contributions, X1, X2, S1, S2, S3. Contributions are always coming from objective function. X1 is contributing 20, 30, 0, 0 and 0. Remember we put a 0 as a coefficient of S1, S2, S3 in objective function, so that it does not have any effect on my profit. Technically my profit is still a summation of 20x1 and 30x2. But yes, these are now incorporated in my objective function. So theoretically my objective function consists of all the variables in my problem. But practically I know very well that only 2 variables are contributing to it, that is x1 and x2. So my table would look like, now what is my IBFS? IBFS is S1, S2, S3 is equal to 36, 50 and 60. S1 is equal to 36, S2 is equal to 50 and S3 is equal to 60. So this is my IBFS. What is this? These are A values. What are these A values? The constraint values. Remember what are A values? We find out theta as B by A. So all these are A values. This is an A matrix. This is a coefficient matrix of all my constraints. Now let me fill up these constraints. S1 is coming from first constraint where we have a 3, 3, 1. S2, S3 are missing, so it is a 3, 3, 1, 0, 0. 3, 3, 1, 0, 0 is equal to 36. Second one would be 5, 2, 0, 1, 0. 5, 2, 0, 1, 0 is equal to 50. Then we have a 2, 6, 0, 0, 1. is equal to 60. Now, if we see our identity matrix, S1, S2, S1, S1 is 1, remaining column is 0, S2, S2 intersection is 1, remaining column is 0, S3, S3 intersection is 1, remaining column is 0. So, this is how our initial simplex table looks like. Okay, then contributions S1, S2, S3 contributions are 0, 0 and 0. These are CJs. Here I will be having my ZJ and then I will be having CJ minus ZJ. What is CJ minus ZJ? CJ minus ZJ is my net evaluation row. This is the row that will be telling me what is my incoming variable and what is my outgoing variable. For now, I need ZJ. ZJ is sum product of respective column with sum product of each column with respective contribution. This column multiplied by respective contribution. So, in this case it will be a 3 into 0, 5 into 0, everything will be 0, 0, 0, 0, 0. Why zeros? Because everything is getting multiplied to 0 sometime or the other. So, everything becomes 0. Then I can have Cj minus Zj, 20 minus 0, 20, 30 minus 0 would be 30. These are our values. Now, the most positive will give me my key column. Most positive over here will give me my key column and incoming variable. A variable that is going to come into my solution. This is my solution, IBFS. So, S1, S2, S3 are my solution. I need to pick up some variable, preferably this 30, that is X2. I will be putting in this X2 in place of S1, S2 or S3 somewhere. But I wish that I could bring in X2 into my solution. Why? Because it is giving me a huge profit. So, if I go ahead and select what is the most positive, 30 is most positive, it will give me my key column. This becomes my key column. X2 becomes my incoming variable. How do we decide who is going out, S1, S2 or S3? We decide by theta. We will find out values of theta. What are values of theta? B divided by respective key column. 36 divided by 3, 12, 50 divided by 2, 25, 60 divided by 6, 10. Which value is least? 10 is least positive. So, this is the outgoing variable. Who is the outgoing variable? S3 is the outgoing variable. Now, I have my key row and this is my key element. So, this is the scenario of first simplex table. Now, let us give it some name so that we will remember it. This was our first simplex table. Now, shall we proceed towards our second simplex table? Let us proceed towards our second simplex table. That second simplex table would be somewhere over here. B and theta, x1, x2, s1, s2, s3. Their contributions are 20, 30, 20, 30, 0, 0 and 0. Now, x2 is coming in place of s3. X2 is coming in place of S3. So, S1, S2 are still intact. S1 is still here, S2 is still here, but in place of S3 now I will be having X2. What are their respective contributions? S1, S2 are zeros, X2 is 30. This much, this is the shape of my new matrix. Now, what about the values? Remember, we have two golden formulae. What are those formulae? I'll write down those formulae over here so that we can reference them. First rule is divide all elements of key row by key element. Divide all elements of key row by key element. This is the rule applicable for key row. Divide all elements of key row by key element. All elements of key row. This is my key row. Divide all elements of key row by key element. This is my key element. Today we are not writing everything kr, kc, ke, incoming variable, outgoing variable, because we have already learned this thing. Today we will just try to solve it and see how we can solve it in minimal writing work. So here I have second rule is that new row is equal to old row I minus key column element I multiplied by modified key row to give me new row I. These are the two rules that we'll be making use of. So we have put them over here so that we can refer to them whenever the need arises. Fine, we'll put them over here. Now let us get on with our task. What is our task? Our task is divide all elements of key row by key element. Divide all elements of key row by key element. 2 divided by 6. 6 divided by 6. 0 divided by 6. 0 divided by 6. And 1 divided by 6. And lastly 60 divided by 6. So it is that simple. Divide all elements of key row by key element. Then second rule, old row minus key column element I multiplied by modified key row is equal to new row. Now I need to find out new row 1, new row 2. In earlier questions that we saw, we only had 2 rows. One used to be key row, the other one used to follow this rule. Today what happens is, one will follow the key row rule, this rule, but all others, in my case, 2 other rows will follow this rule. If you have 5 different constraints, one will follow this rule, but remaining 4 will follow second rule. So second rule is for all. That's why we put this subscript I, indicating which row. Now if I talk of this first row, this formula becomes old row 1 minus key column element 1 multiplied by modified key row is equal to new row. This is how this formula goes. So what do we have over here? 33100. 33100 minus 33100, and then there is a 36 also. Old row 1 minus key column element 1. This is my complete key column. Key column element 1, first element of this key column is 3. Multiplied by modified key row. This is my modified key row. 2 by 6, 1. 2 by 6, 1. 0, 0. 1 by 6 and 10. So this becomes 2, 6 by 6, 1. 3 minus 1 is 2. 3 minus 3 is 0, 1, 0, minus half, 36 minus 30 is 6. So these are the values of my first row, which has been transformed now. What are the values? 2, 0, 1, 0, 2, 0, 1, 0, minus of half, and then I have a 6. It is so simple. It might look lengthy, but it is so simple that I can transfer a row so easily. Now in lectures to come, what we'll do is, we'll try to solve these very same questions, the questions that we have taken into consideration in graphical methods or simplex methods. We'll try to solve them using Excel also, Microsoft Excel. So you can stay updated to see how we can solve all these questions using Microsoft Excel. For now, Second row needs to be transferred. Old row 2, key column element 2, new row 2. What is the old row? It is 52,010,50. 52,010,50 minus key column element 2. Key column element 2. Key column element 2 is 2. Multiplied by modified key row. Modified key row is here 2 by 6, 1, 0, 0, 1 by 6 and 10. What are the values that I get? 30. 30 minus 4. 26 by 6. 2 minus 2 would be a 0. Another 0. 1. 1 by 3. Negative 1 by 3. 20. 50 minus 20 would be a 30. So, the values are 26 by 6. 0, 0, 1, 0, 0, 1 minus 1 by 3 and 30. Now remember one thing, I could have simplified this 26 by 6 to make it, let's say, 13 by 3. But we should avoid simplifying these fractions, the reason being that so long as these fractions are in this shape, their denominators will be same. And if their denominators are same, so whenever the need arises, we can operate upon them very easily. Because if denominators are same, then the LCM will be similar. Whenever we need to subtract or add, for example, we will be multiplying and adding them. So it is always suggested that you should not simplify them, so that I get common denominators and it is easy to add or subtract. In any case, I have my table, I have my Cj values, I can find out my Zj values. Zj values are product 2 into 0, 26 into 0, 0. So these two rows will not participate in any calculation because they are all zeros. This one would be 6, 5, 5 and 2, 10. This becomes 30, 0, 0, 5. This becomes my Zj. I can have my Cj minus Zj. Net evaluation row. This is the row that will tell me who is the next incoming variable and who is the outgoing variable. 20 minus 10, 10. 30 minus 30, 0, 0, 0 and minus 5. So these three are 0. They cannot contribute anything to your solution now. This is negative. So in fact, it will wipe away your profits. It will take your solution to negative. At least it will give you a loss of 5. This is the positive. So this is most positive. Most positive will give me my key column and incoming variable. X1 is my incoming variable. How do I decide upon outgoing variable? Theta. Theta is B by A. Theta is B by A. So B by A. B divided by A. 6 divided by 2. Sorry, we should use this one. 6 divided by 2 would be 3. 30 divided by 26 by 6. Now we have seen a lot of times that the denominator gets flipped. It will become 6 by 26. Now if you can simplify it if you wish to, it will become 15 by 13. 15 6s are 90. 90 by 13. 13 3s are 39. So it is definitely more than 3. So whatever may be the value, it is more than 3. Then this will become 10 divided by 2 by 6. 10 divided by 2 by 6, making it 10. 2 by 6 gets flipped. 30. So this will be somewhere around 7. This is 30. The least one is 3. So you have your incoming variable x1, outgoing variable is s1. In next table, these two will be changed. And this is my second table. Now I can say that this is my second table. So I have my first table, I have my second table. Let us check our identity matrix. S1 intersection is 1, remaining column is 0. S2 intersection is 1, remaining column is 0. X2 intersection is 1. X2 intersection is 1, remaining column is 0. So it looks like we are good up till this point. Now let us proceed further. X1 is coming in place of S1. We did not put this key row mark. This is key row, this is key element. So X1 is coming in place of S1. So I have X1, S2 is still intact, this was X1 coming in place of S1, S2 is still there, and last one is X2 who entered last time around. Now, what are their respective contributions? 20, 30, 0, 0, 0. Here contributions, X1 contribution is 20, S2 is contributing 0, X2 is contributing 30. So these are my contributions. Now can we find out the remaining rows using this formula? What is the formula? The first formula is divide all elements of key row by key element. This is my key row. Divide all these elements by key element. Divide all these row elements by 2. So 2 divided by 2 would be a 1. 0 divided by 2 would be a 0. 1 by 2. 0, half divided by 2 minus half divided by 2. This 2 would rather be like this because this is the divider. So minus half divided by 2. So how do we solve these? We know that numerator remains as it is, but denominator gets flipped. 2 by 1 would become a 1 by 2, making it minus 1 by 4. Minus 1 by 4, and last is 6. 6 divided by 2 would be a 3. Now let us transfer the remaining rows quickly. Now we will transfer these rows really very quickly to see how efficient our mechanism is. We will make use of the same color. Second row, 26 by 6, 0, 0, 1, minus 1 by 3 and 30. Old row 1, old row 2, second row, old row 2. Old row 2 minus key column element 2. Key column element 2, 26 by 6. Multiplied by modified key row. This is my modified key row. 1, 0, half and minus 1 by 4. Minus 1 by 4. So what I'll do is I'll use that minus to cancel this minus and I'll put a 1 by 4 over here. So it is a minus 1 by 4. That minus has eaten up the negative sign and become positive. I've missed something. We had a 1, 0, half, 0, minus 1 by 4 and 3. So this was it. What do we get? We get a 26 by 6 minus 26 by 6, 0. This becomes 0. This becomes minus 13 by 6. This becomes 1. In this case, it will be a 4 2s are 8 minus 8 plus 26. Minus 8 plus 26 is 18 by 24. And then this last one would become a 2, 13. 30 minus 13 would be a 17. This becomes 2. This becomes 13, 17. Now, I told you that we should try avoiding simplifying these fractions. But we see that everywhere I am getting a 6, 2, 4, but 24 is large compared to them. So, I can definitely try to simplify it so that it comes down to level of 6, or this 24 is rather coming over here. So, you could simplify it if it comes down to 4, so that whenever we are taking LCMs, because if I see this is a 0, no issues, 0, no issues, 13 by 3 cannot be simplified. So, let us leave it by 13 by 6, leave it like this. This is 1. Now, this is coming here 18 by 24. If it is possible to simplify and bring it down to level of 4, you could do that. Can I do that? I can cancel both by 6. 6 3s are 18, 6 4s are 24. So, this becomes 3 by 4. Why did I simplify it? So that both the denominators become 4, so that I can take LCM easily. So, these are tricks, these are mathematical tricks more of, which we will learn with practice. So, this is 3 by 4 and last one would be 17. And now, without talking, without speaking a word, I will try to transfer this third row. What you can do is, you can pause the video and you can also try to transfer the third row, and then we will match if our third rows are similar. So, here is our third row, transformed third row. Now, just a quick check at my identity matrix. X1, X1 is 1, remaining is 0. S2, S2 is 1, remaining is 0. X2, X2 is 1, remaining is 0. Identity matrix is intact. Now, if I look at denominators, everything is 4, everything is 6 except for this. So, 1 by 2 can be written as 3 by 6 also. So, you could follow that shortcut as of writing this 1 by 2 as 3 by 6, or we will see when we get there. Now, these are mathematical tricks. You could write this down as 3 by 6 and it would make your life very easy, because everything will be a 6. So you can work out your own mechanism. We'll try to solve them. Now these were Cj's, these are Zj's, Cj minus Zj. So first let us find out Zj, 20. This complete row will not participate anywhere because it will be multiplied to 0. So everything will become 0 sometime. So this will be 20, this is 0, 20, 0 plus 30, 30. This will become a 10, this will become a minus 5. 10 minus 5 would be a 5, 0, 0. This will become a minus 5 and plus 7.5, making it a 2.5. It will be minus 5, 7.5, 2.5. Now let us find out Cj minus Zj. 0, 0, minus 5, 0 and minus 2.5. So at this point I can say that all the values are either 0 or negative. Hence, none of these variables can increase my profit further. And this was our third simplex table. So today also we have our solution in 3 simplex tables only. So simplex stops over here, reason being everything is either 0 in net evaluation row, everything is either 0 or negative. So what will be my solution if someone asks? My solution for this problem would be x1 is equal to 3, x2 is equal to 9, and there will be a slack also, which we need not worry, because ultimately the slack is not contributing. We have a slack of S2, but it is not contributing to objective function. So we can leave it, and Z would be 20 x1 plus 30 x2, making it 60 plus 9 3s are 27, making it a 330. So these are our values. What? This forms my solution, this forms my solution, and this forms my solution. So when someone says that solve the given linear problem using simplex, so this is the given linear problem, this is the process of simplex, and this is my solution. My submission is that you should produce 3 units of x1, 9 units of x2 to get a total profit of 330. This was simplex. Hopefully this will be our last one where we talk about maximization and less than type inequalities. Next time when we meet, we'll talk about greater than type of inequalities. Now remember, maximization has got nothing to do with less than type of inequalities. It generally so happens that maximization comes with less than, but maximization can also have greater than type of inequalities. What students tend to do is they confuse that max should always have less than inequalities, min should always have, minimization should always have greater than inequalities. That is wrong interpretation. Less than and greater than have got nothing to do with maximization and minimization. What we have learnt up till this point, maximization with less than. What is maximization? What is this max doing? This max is doing only one thing, Cj minus Zj. In scheme of simplex, this max is only used to identify Cj minus Zj. And what is this less than doing? It is giving me slack variables. What are slack variables? Plus S1 plus S2 plus S3. So these are two completely different compartments. Max is something else, less than is something else. They are not connected. Generally it so happens that they get connected. Now for the difference point part, the day we come across Z min It has got nothing to do with slack or surplus variables, artificial variables. Z min brings in only one change. That change is Zj minus Cj. No other difference in complete simplex process. If this max was min, if we had min in place of this max, what I'll do is, I'll not calculate Cj minus Zj, rather I'll calculate Zj minus Cj. C minus Z for max, Z minus C for minimum. So, another recommendation would be, before getting on with minimization questions, practice 2, 3, 4, 5, 10, 15 questions of max with less than. What this will do is, it will get into our system that max has Cj minus Zj, max has Cj minus Zj. So that when we get to minimization, it will be obviously Zj minus Cj. Otherwise, while doing the question under pressure or in exam or in internal assessment, we tend to mess it up. We forget that maximization had Cj minus Zj or Zj minus Cj. We get confused. So, in order to avoid that confusion, what you should do is, before embarking onto our remaining journey, practice this. These are very simple questions, practice these, so that these table transitions are very smooth. These table transitions should be like you are adding something or multiplying something. So, once we are through with that phase, we will talk of minimization. Now, we saw that max is doing Cj minus Zj, min will do Zj minus Cj. So, these are not connected. And what will greater than do? Greater than will put a surplus and artificial variable, which will be represented by minus S2, or rather let us call it minus S1 and plus A1. So, slack is plus S1, surplus will be minus S1 and plus A1. So, we see over here that these two are not related. Max is something else, less than is something else. Yes, it happens more often than not that max has these kind of inequalities. We will take up questions where max will be having greater than inequality. So, these two sections are not related. Max is Cj minus Zj, min is Zj minus Cj. This is separate issue. Less than is plus S1 or slack, greater than is surplus and artificial, both come together. Surplus is always subtracted, plus and artificial is always added. So, this we will see when we get there, but for now do not go ahead with this misconception that max is always less than. Max could also have greater than, but for now practice these questions so that we can move through these tables. So, this was it for our today's session. Next time when we meet, we will get into the greater than area. Now, because we have not practiced up till this point how greater than works, how surpluses are introduced, how artificial works. So, in next lecture we will only talk about introduction of surplus and artificial variables, and then we will see how we can solve questions on these. So, this was it for today's lecture, and if you have any comments, queries, do leave them in comment box, and if you have not subscribed to this channel, do subscribe, and thanks for watching. Bye bye, take care.